Hello guys, I'm back. We're going to go over where I'm at on this radio. Got the band switch in, and that's what we're going to primarily look at today. I wanted to kind of discuss this particular switch because it's kind of uniquely drawn on the schematic here, and I want to discuss how to follow it out on the schematic, and both from a standpoint of just knowing, you're working on the radio or whatever, and it's in the radio, it's all hooked up and everything, so that you can figure out exactly, what hooks up to what, as well as if you ever had a radio like this or where it's depicted this way and the switch is out and you need to rehook it up. The first thing, if you notice on the schematic, there's basically three switches. 1, 2, and 3. The other thing too, on any schematic that on any radio has any type of band switch or something, there's going to be some information about it. Here it discusses it, talks about 3 position rotation clockwise. Positions are broadcast, medium wave, and short wave, and the different positions. Here it states BMS, B being broadcast, medium wave, and short wave. So the radio, and which is standard practice on most schematics, is already in its broadcast switch position. So, and it shows here an arrow pointing this direction. So when it rotates, that's the direction of all the switches as they move. Again, another arrow here, and then this one here showing these two. Now, whenever you're dealing with a schematic and a switch, some of the things that kind of help out, there's various techniques, there's various ways, and no one way is perfect for all radios. But look for stuff that is rather obvious, either connections to things that are very large, easy to find, to certain things about the switch itself. In this case, you notice you only have one wafer on this switch, and a lot of switches, band switches, will make use of both sides of the wafer. There's some switch connections, or an actual switch on the back side in here. You can see some of the contacts, and then there's switches on the front. If it'll focus, maybe it will. Yeah, okay. Now, so what do you do to try to figure out the switch? Well, one of the things you can do with this switch, this one in particular, and again, in general, you have to kind of look for any connections that you can easily trace. You may have a connection on a band switch that may go right straight to a tube socket. You may have one that maybe it has a switch in there, and the one of the position is, say, phono, and you'll have a back here in the back of the radio a phono plug, and there'll be a wire, a couple wires there, but one wire will go right to the switch. That's, you can find that phono plug real quickly, and then you can trace that back to the switch and at least get one contact found. If it goes to one of them goes to a tube pin, you can find out which tube it is, what pin it is, and that'll help you. And various things, maybe a particular coil that you exactly know what that coil is. You can pick out, well, it goes here. So there's various techniques depending on the radio, depending on the switch. These come in different varieties. You can have like one wafer, you can have 2 wafers, 3 wafers, 4. You can have, just on one side of a wafer, and just one side. You can have it on the other sides. There's just a whole gauntlet of different switches and different designs and different things. Now this particular switch, on it, if we look at schematic, we have 3 contacts. This one here, 3 contacts. But this guy right here is 4 contacts. Now we can take that even one step further. In 3 of the contacts appear to be the same length right here. So as the switch moves, they get contacted in. This one here though seems to be shorter, and it seems only going to make contact where this part here seems to be longer. So from this information, what you can do is okay, we've got 3 contacts here, 3 contacts here, and then one with 4 contacts. There are 3 switches on one switch. So the easiest right off the bat is to find the one that's abnormal. It's got 4 contacts. So then what you do is you start looking at the switch. Now if you look here on this side of the switch, well, I've got a switch here and I've got a switch here. This one has 1, 2, 3. This one has 1, 2, 3. And as I flip it through, you'll see that that's all it does. It's the only contacts that are made. So those represent these guys right here. Okay, and we'll get to which ones are which here in a minute. We want to find this guy. So what's left? Well, it's just what's on the back. There's 1, 2, 3, 4. Okay, that's fine. So that must be my 4 contacts. And it's kind of hard to see. You know, it switches through. I think to a certain extent we can probably watch it. Maybe if I can get in here good, you can see it turn through. Now the thing I want to first of all to notice on the schematic is in broadcast mode there's 1 contact on each switch. It's always making contact, so it's kind of a common contact. Here it's this one, and we'll follow it out here in a minute. Here it's this one, and here it's this one right here. And that one goes over, it comes up, it comes over, and goes to T4 coil. Now, as it switches through this, you know, these commons always stay in contact. So as this switches, the next position it's going to take this one and this one in place. These 2 will be in contact. Next position, this one, and this one's in contact as well as this one. It's only 3 positions. So if you visualize it, or you could draw it out where it's clear across, all 4 are then in contact. We can watch that a little bit by looking at the switch. First, and I know it's kind of dark in here and I'm sorry about that, this guy right here is already in contact. The switch is really running from here down around, and you'll see it as I rotate it there. That's the next position. This one stays in contact. This one now has come in contact, and as I rotate it, boom, now this guy down here, this one and this one and this one now is in contact. All 4 are in contact, and it's really hard to see. Right here you can see that this guy is the shorty. He only comes down right about right here, and these guys are longer. So when I go back to broadcast band and this guy's the only one in contact, then I know from the schematic that this wire right here, the blue wire, is must be going to coil T4, because he's a common. He's always in contact. So I can follow him back to T4 here, and I can follow him back, and he comes down and he hooks right down here. This section right in here, this part, is part of T4. Now, this guy here, the shorty, comes down and comes across back up to one of the tickler coils. Alright, it's part of T5. So we can follow him down, and he's attached right here. And that's where it should be connected, on here between these two. Now, I don't know if I can get it close enough up, but there's two wires actually connected here. One of these wires hooks to this one, and one end hooks to this one. That's the common between the two, which is also the common in between these two guys here. That's that connection right there. So that's him. So now we've established these two guys. The rest of them, well, we just start looking, and we flip it in, since now we know by looking at the switch that in the next position it moves over, and we've watched it, and it makes contact with these two as we rotate it. And I know it's kind of hard to see. The other two will be easier to see. And then I can follow that wire, since now I know that these two are the only ones that are in contact. And if I follow right here and and you can draw this in, that when just one position, just these two is going to be contacted. We've already figured out this one. We can follow this one and follow it down to this point here, and that corresponds to this connection right in here. And there is a connection there. It's very hard to see the dot. I didn't blow this up enough, but on the computer I can blow it up to see that there is a connection right there. There is a dot there. And then the last connection has to bring in this wire here, which goes over to C6 and C7 and to ground, which happens to correspond coming over here to this point here. And that's, you got the C6 and C7 here, and one of them go down to ground right here, which is also the ground for the tuning condenser. Excuse me. The weather's been such weird, it's been kind of fighting a cold. So anyway, that pretty much deals with how this switch is working. As you rotate it through, it's just, all it's doing is moving this over, and you can start counting out the connections where it hooks to. You find your common, locate it and where it hooks, and then you just then imagine it or draw it in. The next position will be just these two contacts, and the next position all four bring in. You start locating one, locate the next one, and then it's just easy to start following. This one here particularly, one of them is shorter than the other three, so it's easy to find, and so on. Now let's look at these two guys here. And they'll be easier to see because they're not on the back and they're kind of hidden. And that, that's sometimes what you run into, because some of these switches could be, like several wafers or even two wafers, but with one wafer pretty darn tight to the chassis where you don't have a whole lot of room to look down into it. And sometimes the ultimate best thing to do is try to use a continuity tester on your meter, here where it buzzes. Of course, just make sure that you may be connecting in some really low ohmage coils. Some of these are less than 1 ohm, so that's going to make it buzz too. So you kind of got to watch it. Sometimes you may have to make temporary disconnects to try to figure out a switch if you're going to do it that way. Now, let's take this one first and let's look at him. Let's see if we can find where he's at. So anyway, we know our common, our broadcast, comes up. It comes up to here. It's hooking to a coil here, large coil, 37 ohms. Then also goes to ground. It also has, it says black ground. This is antenna lead coming off. And here's the antenna, tan colored wire. In my case, I actually put white because they really have tan. Could have used orange. It's kind of close to tan. But it goes out to the antenna. So let's see if we can find that. So let me kind of stand up here, moving around a lot. Here appears to be a coil. I mean, we can look, and here's our antenna leads. We follow them back through the tie. Here's black lead, which is ground, and it goes down here to a point here on a tie point and comes over to a ground connection right here. And then that leaves the white wire as being antenna, so we follow it up. Hooks to a coil here, and we could do a little checking and see that it actually hooks to this one here, this big coil, which is about 37 ohms. And we can then follow this wire out, and it hooks here. So what is that? Well, that happens to be hooked right here. So if we switch through, we can see the other two of the three connections that are made by switching it through. So now we've found that guy, which is this one here, going right to here. Now, the first position after that, remember the first one is broadcast, the next position is going to be medium wave. That hooks to this wire here, which then goes up and across into a tickler coil right here, or a small coil that goes to ground. So let's find out where that one goes. Well, we can then switch our switch in place. It's connecting these two, so that runs across here to this brown wire, which comes down and consequently hooks right to here, which is that coil. Now we've found those two. The last one is the third position, which comes up and hooks the other one of those coils. We go down here, look at our switch. Now we're connected in. Blue wire comes across and hooks to the other one right here. And if you look real close, there's two wires coming up through. There are actually two wires coming up here, and it's kind of hard to see. That hooks to the black, comes across here and hooks here, down to here, to our ground point. So that's the other side of these guys, which is the grounds. Now we found that switch. Take it back to broadcast. Let's locate this one. Well, according to the schematic, it says that in broadcast mode it hooks to R1, C1, and then a coil, T1. Well, we can try to look for those. R1 happens to be, I do believe, 100K, and C1 is a 0.05. So we only have one switch left on here, so that's got to be this guy here, because that's the only one we haven't looked at. And we flip it through, we can see what ones it hooks up. We can follow this guy through, find it, take it down, feed it through here. It comes to this point right here. There's a coil hooked to this. There's a capacitor here, which is a 0.05, and buried underneath is a dog bone resistor. That's brown, black with a yellow dot, 100K. And by the way, all these are restuffed caps, and that's what I'm doing in this, is restuffing them. That brings up that one there, so that's got to be the broadcast going up here. We can flip through, and we see that when we do that, we hook into this wire here. That comes down here to a coil. What is that acting as? Well, if we come back to the schematic, that turns out to be this wire up here going between two coils, or actually the other side of this coil, and then this coil here. So it's in between these two coils, two trimmer caps, which happen to be this one. Here's the two trimmer caps and the two coils. Now, the last one is this guy here, which comes down to here, and we flip it in. That'll be our last switch in, which will be just further up the line, hooked here. onto the end of this cap, connected here, and through. So that'll be this guy here. It's going to be between these two coils here and the capacitors. And of course the other side of that then will go up, hook to the tuning condenser into the tube, which is this green wire, which is kind of hard to follow, but it goes through here, comes along, hooks to the tuning cap right here. And on the other side of the tuning cap is another wire that's got a grid cap, because this tube actually has a grid cap on it, and hooks that grid. So hopefully this answers some questions and understanding on how the switch works. I'm probably going to do another one on just switches in general, even a little more general, because I know rotary switches can be kind of pain, and I don't think I can go over them too much. They can be a pain to look through, and there's various different ways that they're depicted on schematics, and so I'm just hoping that I've answered any questions on how this is depicted here and how to follow it out. So anyway, I did want to answer one little question that was in the comments real quickly here before I end this video. I was wanting to know about the size of this pattern. It's around 80 to 220 picofarad. It's the low frequency pattern on the broadcast. In other words, according to basically the instructions for alignment, you set her to 600 on the dial, which is 600 kc, and kilocycles, and then you rock the dial while you adjust this one to get it in to maximum level on your meter. The reason for its size is it is a fairly large condenser pattern cap, but it isn't like you don't see these in pretty close to that size. You see them more like what I'd call standard size, or something kind of similar, somewhere around this size, or one of these guys down in here size. The difference is I think this one only has 2 plates on it. The ones that are in the smaller package size has like 4 or maybe 6 or 8 plates that are in there, metal plates. This one I think only has 2 too, but it's a low picofarad cap. And but in later radios they would one thing that they did was they actually added more plates. More plates, you have more capacitance, so you can make the package smaller. So anyway, I hope that answered that question. And on the next video we'll go on this radio, some of the other connections that are being made and where I'm at there. And I will be doing a video on theory probably tomorrow that will be talking about, I believe I talked about, when I was talking about the coil hookup, I made mention something towards the fact that this goes back to ABC, and it is establishing bias for the 6L7. So that's actually through the ABC circuit, and we'll discuss different techniques for doing that, different ways of doing that. There are different, some radios use both diodes separately, some connect them together, some just use only one diode and take the other diode back to cathode and ground. So we'll talk about how that is established and that voltage is established, and how it works in that theory video. And I'll be trying to get a math video up too. So anyway, thanks for watching, guys, and I will try to answer some of the other comments. I really appreciate your comments. I appreciate you watching, and again, I hope this clarified a little bit about the switch and how it operates, and on this particular radio. So until next time, thanks for watching, and thanks again for your comments.